What happens if nothing happens? This is the story of the princess, the P and the LOD. As we said in some of the previous videos, whenever we measure something, we have to deal with uncertainty, measurement uncertainty to be precise. But what if we measured something, say caffeine, in this decaf cappuccino, and we didn't find any caffeine? Does it mean there is really no caffeine in that cappuccino?
What's the point of the decaf anyway?
Well, you've got me there. Uncertainty is equally important even when something is too small to measure. If we cannot find any caffeine in that cappuccino, we cannot say that caffeine is not present. We can only say it's not present at or above what we can measure. Say about 60 milligrams of caffeine per kilogram of coffee. This is what chemists call a limit of detection, or LOD. In this case, the range of possible values within which the true value of caffeine lies is between 0 and 60 milligrams. It's sort of like the story of the Pea and the Princess.
What's the Pea and the Princess? And can I have a cappuccino, please?
Once upon a time, there was a prince who wanted to marry a princess. But she had to be for real. There were princesses out there already, but it was difficult to detect the real ones. One evening, a terrible storm came on. Suddenly, a knock, and the old king went to open it. It was a princess, standing out there in front of the gate. The water ran down from her hair and clothes. She was a mess. And yet, she said that she was a real princess. "We'll soon find out," said the old queen, who was probably a scientist. She took all the bedding off a bed and laid a pea in the bottom. Then she took 20 mattresses and laid them on the pea. On this, the potential princess had to lie all night. In the morning, she was asked how she had slept. "Oh, very badly," she said. "Einstein only knows what was in the bed, but I was lying on something hard. I am covered in contusions, probably due to localized bleeding that has extravasated into the surrounding interstitial tissues." Just because she was a princess doesn't mean she didn't have a medical degree. In any case, now they knew that she was a real princess because she had felt the pea right through the 20 mattresses, and that was their mutually agreed objective standard for princess detecting. The princess is like an extremely sensitive pea detection apparatus. But if we added another mattress, the princess might not detect the pea. It's the princess's LOD. But she certainly would be able to detect a golf ball. Some princesses will be better at detecting peas than others. So if the princess reported no foreign objects under the mattress, a scientist would say there were no foreign objects detected by that particular princess, rather than there was no pea. But she would be fairly confident there was no golf ball. So what have we found out today? Uncertainty means there is a range of possible values within which the true value lies. This even applies when something is too small to be measured. When something is too small to be detected, the range of possible values within which the true value of a measurement lies is between 0 and the limit of what can be measured. Why does this matter? Lots of reasons. Let's say we were interested in a toxin in the environment and we'd taken a whole lot of measurements and we didn't find anything. Just to be super cautious, we may decide to assume that it's there at the level of detection. That would be the worst case scenario in that case. Or perhaps we're interested in something being free of something, say gluten-free. But we can only ever be sure it's as free as what we can measure. Of course, it has to be in there in the first place. There has to be a probable reason why it's in there. For example, I'm pretty sure that this eggplant is free of kryptonite.
So am I, because kryptonite isn't real.
Fair point, that's why I'm sure. In any case, thank you for watching. Subscribe to the channel, leave us your comments, and I'll see you soon.